Hi, good morning, everyone. Good morning and good morning, everyone. Thanks for joining the session. So the last week we had an we have a discussion on the generative AI topic, right? Like what it means, generative AI, and we have seen that a couple of terminologies like the lang chain, and along with that how to implement like in a GPT-4 if it is in a cloud-based technologies like in Amazon or Microsoft GPT, Microsoft Azure and GCP based approaches as well. Then we have seen the couple of few shuttle learning algorithms as well, right? Now to start this generative AI concepts, like majorly we understood that NLP is the one of the subset for the AI, right? When we started initially day one class, like an AI is divided into the two subset industry. One is computer vision and another one is a NLP, right? NLP stands for natural language processing, or generally people call as a natural language understanding, natural language generation. Okay, NLG, NLU, NLP. The people will call with the different norms as well. So each and every the comes we will each and every kind of terminology will handle with the text based informations only. Okay, we'll see the today's session. So we are going to cover up what are the general text pre-processing or text mining steps as AI developer will do. Okay, in day-to-day is job activity. So as he is a data scientist or he is an AI developer, so when he receive the data, as soon as he receive the data from the business stakeholder, so he'll identify and he'll analyze the data or what type of the data which we have. For example, okay, for example, consider this is a one of the data sets. Okay, so generally the data sets look like this is a, consider this is a one of the ML email based the use case. Okay, given the email information, so we need to identify that whether the email belongs to the specific X category or Y category. Okay, the data which you are seeing here, this is the real time data which I processed from the .msg files. So when you are doing the outlook, right, when you're working with the outlook, if you wanted to extract this outlook information, that will be stored in the .msg files. Okay, so all this information which you are seeing is a mail based conversation. This is one of the real time data. Okay, this is the one of the real time data which we are working for the client. Okay, this email information, this basically this email data having the legal based information. Okay, the legal team is trying to conclude the particular mailbox belongs to the like in a consumer based mail confirmation, or it is in a product based email conversation. Like generally we see that email is a spam or not spam, we see that, right? Similarly, in specific to the industry based on their email conversation, because in every industry they have different teams, right? Like in a marketing team, finance team and legal team, each and every team, they have their own responsibility, job responsibility, so they work for their duties, right? So consider this mail information, this all the mails are the legal based. Like when the company is like doing an MOU with another company, they have some formal conversations, right? So all the formal conversation which you can see in this mail information. Okay, when you extract the .msg files, okay, you see this all the like in see applied for the new trademark. Trademark is nothing but the license, right, for the one of the product. So kind of this information will be presented. Okay, so generally when you're working with the NLP based use cases, so you see the data information, like some of the characters will be the upper cases, some characters the words will be the lower cases. So some of the words will be starting with the starting character will be the uppercase, and following the other characters will be the lower characters. Okay, so this all type of the junk data which we see when we receive the data from the business stakeholders. Okay, this data we are going to handle with the NLP techniques. Okay, so this is the majority of the use, any kind of use cases. You take any kind of use case information, either if you consider the you wanted to do some sentiment analysis. Okay, if you wanted to perform some sentiment analysis also, there you might be receive the similar kind of the data, but those data belongs to the reviews of the particular restaurant. Okay, consider if you are visited for the some Taj hotel, and then you had some great dinner with your family or with your friends. So then as soon as you come out the Taj, or as soon as like you you once you into the house, then what you do, you will do the some reviews for the hotel, right? If you, what type of the experience you have faced about the Taj hotel. So in the, just you are going to the Google, and you are going to give the review for that hotel. So then based on that review, we'll analyze that this particular the customer has experienced as an the positive way or the negative way. Means like, and if he experienced like, some waiters has been misbehaved, or the food was not great as expected, or like the order they ordered 30 minutes ago, but it was delivered in 1 hour. Okay, these kind of the experience. Or sometimes the people will return, hey, the food was very delicious, and it is an awesome experience. So these are kind of the various the responses which we'll receive for the particular reviews, right? And along with that, sometimes the people might use these special characters as well, like an ash, and some emoji symbols as well, right? Like the some of the special emojis, like a smiling, loving, kind of the dislike symbols. They use various symbols as well. All the special characters which they are trying to tell the emotion of the information for the particular incident which you have faced. Okay, so now, as you are seeing this the data, so how will you handle in the real time, right? As I tell, this is the data which is belongs to the NLP use case. So to handle this the NLP approaches, because we cannot process all this chunk data, right? Just consider this is the one word like in a sub stg one which is there. This is this particular information which is not belongs to any of my conversation, right? Which is not providing any contextual to identify this email belongs to the particular consumer level trademark or non-consumer level trademark, right? You're getting right. So these words to be eliminated, how we are going to analyze this, what type of the words we need to remove. Okay, what types the words which we need to be considered for to be make the machine learning model to be trained. Okay, so before doing any model training, either you go with the machine learning based, either we go with the deep learning based, either you go with any other approach. Okay, so before that, we process the data. Okay, we process the data here, and then we process, once we process the data, that we call as a text pre-processing or text mining. Okay, so in every interview, okay, they ask you what are the basic text pre-processing steps you will be follow. Okay, so why what is the importance of this text features. Okay, what is the importance of this text pre-processing, what did the pos tagging will do. Okay, all kind of this, the operations which we performs, which we are going to discuss in the next 30 to 40 minute session. Okay, I hope you guys are clear with this data set. Okay, why I wanted to show you this data specifically, because you need to see that, because like the real time data, how this data looks actually. Okay, see, some this particular email conversation will be having some 500 to 600 words, sometimes 4000 to 5000 words also will be there. Okay, you can see that. See, the starting of the chunk, it's the starting of the words is completely irrelevant, and which is not required only, which are all encoded. But you see, as soon as you are into the center of this text, like in the middle portion, you can see the some important words which is presented. These are the words which is very very important for us to analyze and to come to the one conclusion. Okay, for to tell that this category belongs to X or this category belongs to Y. Okay, so let's see, and we'll see one more review of the data set as well. I will show you one more interesting data sets. Like, and as I told you, if you're like an as a you're a data scientist, you are working for your the for restaurants. Okay, you have to analyze is the restaurants. So what, how these restaurants particular, suppose you're working for the Zomato, you can consider. Okay, online food delivery. Okay, so there are multiple restaurants who are the partner of this Zomato or Swiggy, consider, or the major any food chain industry. Okay, so as you are working for this industry, so you have to analyze is the user experience for the which restaurants performing the better, which restaurants performing the poor. Okay, so what these people are saying about what is the complaints information. So all these activities which we need to perform. So when you are performing, you see that these are the kind of the data which you see. Okay, hey, wow, I love this place, or wow, this restaurant. Okay, or wow, I love this food. You can see the fries were great too. And I tried Capicode, Ravoli, and chicken with cranberry. And they, you see, they have used some special characters, dot, 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 this MMMM and explanatory symbol. Symbol means they are liking, they are expressing their about the, the kind of the love or the feeling which they have seen in the, they presented in the restaurant. Okay, so consider, you have to consider in these use cases. Okay, when we receive this data, how we are going to handle. Okay, in the text industry. Okay, and there we will see couple of industry use cases also. If it is a financial, how we are going to do as well, how to analyze these various text pre-processing. Okay, let's jump into the NLP. Now, as you've seen that, because NLP is something which is in a field of computer science only, that enables the computer to understand the generated human language. Because these restaurant reviews or the information which you have seen, these are generated by the human. If I pass directly to the system, will the system will understand about this concept, this about this information? It won't, right? So we need to perform some analysis. Because system only knows the numbers, that is 0 or 1. Okay, apart from that, machine doesn't know that. So we need to perform into the computer understand language. Then only we can process the other steps to analyze what kind of these numbers are saying to us. Okay, so this is the very interesting field. Every developer, they do the minimum. Okay, they spend most of the time into the NLP only. Okay, some industry they might be expect you the computer vision. But even in the computer vision, because if you're seeing for some images, so from the given image, suppose you consider this is the image, scanned based document. So you have to extract this information. After you extracting the information, that is known as a text only, right? The text you need to be analyzed and processed. Okay. For every industry in the AI, the NLP is the NLP is a the very high level the terminologies, high level technology which can be, which we can be considered. Okay, so that is the important. So please follow with the steps. Okay, the steps or the techniques which you are going to utilize, which we are going to see. These are the common steps for whichever the data you are going to apply. Okay, for any data for any business industry. Okay, it's all about the context. The context, well, if you're working for the semiconductor, might you see the some test cases for the microprocessor and microcontroller. So you will be perform some other kind of test cases. I will going to share you my experiences with the various industry, how I handled, how I tackled as well. So based on that, I have added all the text preprocessing techniques as well here. Okay, so these are the four topics. These are the core NLP topics, four core NLP techniques, which we are going to see in today's discussions. One is text pre-processing. So as a text pre-processing, I told you, whenever we receive the data, as you seen in the Excel file, so this is the one of the row, right? This is the one of the mail body. So like you will be having hundreds of mail bodies. You can see that this is a 17,428 sample records only. So just consider how many of the emails, like there will be the millions of the data will be presented in the email. Okay. So each and every email body, like which you need to handle, each and every row you can consider as a one document. Okay. So each document need to be processed, because each document will contains around 4,000 words or 1,000 words, 500 words. Okay. It depends upon the nature of the data which we are working. Okay, so that's all like inside the data. So that in text pre-processing, what we do, so we, as we have seen this data, there are a couple of words which are in the uppercase, which is started, then followed with the lowercase, right? And the same word, sometimes we see that all the characters will be the uppercase. Okay, sometimes we see the same word like an NLP which you are seeing, right? The same word you can consider it will be the lower cases. Okay, so that is the difference which we need to understand. Suppose NLP, okay, and NLP, NLP. Some people will write like this. Some people will like these approaches as well. But as the human, as we are the human, we can consider all these four words saying the simple word as an NLP, right? Because person to person, when we see the documents, when we see the number of rows, some of the similar words which presented in different type of the writing mechanism. Okay, but finally these words will be the similar context, that is the NLP is the one word which is saying. Okay, so these are the kind of interesting things which we are going to handle in the text pre-processing. Okay, like trying to taking the meaningful units like words and sentences or subwords, and cleaning operations like in removing the special character like an ash or special character emojis or extra spaces. Okay, sometimes in your email body or sometimes in your data there are emails also will be present, because when you extract the email information, so it might be the some forwarded mail from whom you have sent, from which person the mail has been triggered, who are the mail persons has been presented, all the specific the users information also will be presented. So based on those user information, which it won't be helpful for to classify, right, the to identify that information. So those are information which is not required by at the rate gmail.com or at the rate outlook or at the rate arisglobal.com or at the rate of xyz company. Okay, so we'll remove those informations. Okay, so handling with this text pre-processing, so we are going to see in detail in the coming up. Next, morphological analysis. What is morphological analysis? See, the same word, some people they will write in the words like hey, I love this place. I love this place. Some people, I love this place. Okay, and some people say that I love this place. Okay, the same word, if you consider love, loves, loved, this is the root word. Okay, the same words they are expressing into the more in detail, the more deeper. Okay, that's we call as a morphological analysis. So how do you handle, because when we see these type of the words, so how we are going to handle, so that techniques we are going to do in the morphological analysis. Like you see the example as a running will be considered as a run. Okay, runner will you consider as a run. So these words can be made into the root words, so with the help of like stemming technique and lemmatization techniques. Okay, so we'll see that we'll try to identify the root words by with the help of lemmatization and stemming techniques, and we'll see what type of the libraries are providing for this to do this. And next is syntactic analysis. Like you consider, you have to identify the the text generation. Okay, when as you seen in the email, right, when you're writing the some email, there is the text will be appears, right, as soon as you see here. Suppose if you're writing for one email. Okay, leave. Okay, some medical leave you're writing. It is not activated text generation, but as soon as you are writing this email, it will start generating the words, right? So that words will be followed with the previous word based on the context. That is a previous tagging system, whether the word next word should be the noun or whether the next word should be the pronoun. Okay, so all this kind of POS like parts of speech tagging system which we are going to do. Okay, so the making of the sentences like text generations and kind of applications which we are going to do. Okay, so that is called the parts of speech, like nouns, verbs, adjectives, and other kind of around all the pivot tagging systems which we are going to do. Next is so we have done all the text pre-processing steps. Now we need to make a some text representation. What is mean by the text representation? Text representation means the information which is there as a human readable language, that we are converting to the numerical base, that computer readable language from the. Okay, so converting human readable language to the computer readable language, that operation can be performed in the text representation, because now all the text pre-processing we have done, all the unwanted information we have been done, then we will jump into the text representation. So in text representation, we are going to deal with the various techniques like in a bag of word, counter vectorizer. Okay, and the TF-IDF vectorizer, TF vectorizer, word to vector, gensim word to vector, and average word to vector. Then you will be having a universal sentence encoder, global vectorization. Okay, and even you can use the generative AI based embeddings as well. So all these embeddings concepts will makes to the computer readable information. Then only we can able to train the machine learning or deep learning, right? When we wanted to train any model, because that input information should be in the numerical representation. That numerical representation we are doing in the text representation steps. Okay, these are the four core techniques which we are going to apply in our day-to-day job activity, day-to-day our jobs. Okay, everywhere in every industry, these steps are the common. Okay, whenever you start any business use case, as soon as you see this kind of the information, when you wanted to deal with the email based data, or when you wanted to deal with the some of the customer complaints based data, or when you want to deal with the bank transaction. Okay, whenever you make the transaction, there will you will get the description for the statement, right? So if you see for the any banking, like in the US or any kind of banking, you see that statement. Okay, so this transaction has made for this rider, like an LYF is the company name. Along with that, the amount also will be appeared. Okay, so these kind of informations which we are going to handle. Okay, so let's jump into the in. We'll try to understand each and every technique in detail. Okay, yeah. Now, as we seen that, like in a text pre-processing, right? In text pre-processing, we have understood tokenization. Making the word to be the lower cases, and then other technique processing which we are going to apply, right? Removing the special characters and other approaches. Let's see what is tokenization. Tokenization is nothing but you will be having the group of information, like as you see here. Okay, this is a complete one information, this is a complete one document, right? Or this is a one complete message information, you can say that. So any given paragraph, or so paragraph, we are going to split into the word levels. We are going to split into the each every word. Okay, so that you can see that. For example, you have the statement like in a the quick brown fox jumps over the lazy duck. This is the one sentence, or this is the one kind of document you can consider. Okay, so now what we do in the tokenization, we are going to split this sentence into the multiple words. Okay, with this following, you can see that each word will be separated with the comma. The quick brown fox jumped over the lazy and dog. So now we have seen that like in a tokenization will help to split the sentences into the words, right? But why we need to do this tokenization? What is important in the NLP technique, right? As I tell you, because when you wanted to perform, when you wanted to perform any POS tagging or stop words, or when you wanted to do some lemmatization, stemming, all these techniques can be performed in the word level based, not the sentence level based. Okay, that's why it's very important for us to do the tokenization. Okay, before you're doing the tokenization also, you can perform complete this string sentence. You can perform to the lower case, then you can do it to the tokenization. Even once you make the tokenization, you can convert to the lower case by using the simple dot lower. Okay, suppose you have the NLP is the one word here you can consider. Okay, I'm creating simple sentence a dot lower. See, you can say that it directly sentence allow you can consider by passing the lower, then you can perform the tokenization as well. Okay, so later also, once you convert the tokenization also, even that you can perform the lower method as well. Okay, so this is the tokenization. Now you I hope you got to understand why we do the tokenization information. Okay, tokenization will help you to do the next steps, like in the text pre-processing steps, like in applying the stemming and removing the stop words and removing the the portal stemming, or like lemmatization, or any kind of techniques. If you wanted to apply that, techniques can be applied only the word level, not the sentence level. Okay, so that's the importance of the tokenization. There might be the word tokenization will be there, and there might be the sentence tokenization will be there. So depends on the context, like in which the context, or the depends upon the use case which you are working. Based on that, we are going to use that. Okay, either it might be the word tokenization, either it might be the sentence based tokenization. Hey Venkatesh, if it is in a sentence based tokenization, how it is going to split? So each sentence will be whenever the sentence is completed, that sentence is completed, we can indicate that with the dot symbol. Means we can consider that sentence is completed and the new sentence will be started here. Okay, so this sentence can be splitted with the dot. Wherever from the dot it end, then that can be considered as a one sentence. Okay, so next we'll see that one more stemming. Okay, so we'll see that one the examples as well by the time. Yeah. Okay, so here, see, to implement this all the techniques, we have the package called NLTK. Okay, what is NLTK? NLTK stands for Natural Language Toolkit. Okay, now the kind of steps which we are going to learn, all these steps can be implemented with this NLTK package only. What is package or what is library? Package, or we can call like, or framework, you can call any name. Okay, these packages or framework library will help us to make the code to be minimal code, like, and to make the code structure to be the minimal. Means you no need to write like in 100% of the code. The already code has 75% of the code which is already written. We are just utilizing the by calling of the package name, so that we can build only 25% of the code. That is the use of the package or library. Okay, so to perform any kind of NLP operations, NLTK package is a much very important for us. Okay, so how do we install the package? As we know that pip space install and NLTK. Okay, it will install all the packages here. Okay, so once you install the package, so you can import this package as import NLTK, as you are seeing here, import NLTK, and from there you can perform the specific operation, like when you wanted to perform the tokenizers. Okay, you can see that word tokenizer example. You have the natural language processing is a fund. If you want to you need to do the word tokenization. You can perform the word tokenization as a here, like in a individual word, like natural language processing is one. And if you wanted to perform as a sentence tokenizer, you can do that. Okay, so let's see word tokenizer and sentence tokenizer. This is how we import NLTK, and from NLTK tokenize, import word tokenize and sentence tokenize. Okay, let's recall. So I'm just reading of this one. Okay, this is my input document. This is the information which I have taken for to show you the example for you people. You can take any information. The real time which I said, the information which you are seeing, very simple, but the real time as you see in this example files, right? This is how it looks. Okay. So next is I'll just perform the word tokenization. So simply you just call this word tokenization here, because you already imported the code part. So here you no need to use the split or something, because the split and ever other mechanism can be handled by this word tokenizer. Okay, inside the word tokenizer, which is they already have written how to split, how it has to be considered as an approach when we are looking for the word tokenizer. Okay, as based on the space or based on the comma separated or based on the double space mechanism. So it can it has have some set of rules and everything. Okay, so just we are initialize the object as a packet as a word tokenizer. Then we are calling as a word tokenize by defining the object as a words. Then we are passing the input variable name as a document, so which contains our text information. Okay, now I will print this. See, you can see that when you are splitting this one, so all the words which is splitted, it will stores in the list variable. Okay, because list will store multiple values, multiple data values, right? So you can validate print type words. You can say that this word of the variable which is storing is a list data type. Okay, so this is how it will come. Okay, when we do the word tokenization, let's do the sentence embedding now. Okay, I'm just calling the sentence tokenizer, which is from the NLTK package, NLTK toolkit. Okay, So even you can see the many of the NLTK. So by, okay, if you DAR NLTK, if you type, these are all the operations which you can perform. See, see, here you can see that NER tagger, sentence tagger. You are seeing that, right? Sent underscore tokenizer, right? It will be there from in the tokenizer. It will be available. Okay. So first we need to find the tokenizer, then we can get it. Okay. All these are the various operation which can be performed. Like similarly, how we do the tokenizer. Okay. See, POS tagging, POS tags, sentences, and other methodologies also. Sentence tokenizer, you can see that, right? Sentence tokenizer. Okay. From this, dir is a specific inbuilt keyword. Through the inbuilt keyword you can see what type of the operations can be performed this library. Okay, that is also one approach which can be verified. And this is what we see in that, right? Sentence token means, you can see that, right? As I told you, where the sentence ends with the dot, so from there it will split the sentences, right? As I told you, this is the original sentence if you consider. So here it is ended here after artificial intelligence, then again it started with the, it helps computer to understand and process the human language. So if you see that these are the two sentences if it is there. So exactly the when we use the sentence tokenizer, it is splitted the similarly as we have expected. Okay, so this is how we do the sentence tokenizers as well. Okay, let's jumping to the other concepts. If you want to do with the real time information also, we can copy. See, this is how it will be there. See, you can see the in real time data, there is a lot of junk, right? Which is on required zeros and zero W. Okay, all this can be processed. Okay, I will show you the type of interesting techniques also how to handle, because there is no meaningful of this single character, right? So what it means this BH actually, there is no importance only. So these are the kind of the information they expect the interviews. Okay, how you are going to how you are handled in the NLP data. Okay, when you are seeing this data, so either you consider this the single character values also while for model training and everything. Okay, so this is how it will looks when you see that the A W. Okay, and okay, E. These are not the interesting keyword. This is not having the any weightage for to take up the decision of our data. Okay, so I will tell you like what we were going to do. So now once we split it, okay, we will drop all the single characters also. Okay, single characters or the two characters which is having the two characters in the words. We will drop those characters as well. Okay, VOU is which is not meaningful word as well. Okay, so we'll analyze the data first when we do the stemming. Okay, when we do the word tokenizer, we'll see that okay how our data is distributed across. Okay, how is my data set is available. Okay, so then we'll do going to do the trigram, bigram, n-gram. Okay, so with the help of this trigram and bigram technology, we can analyze how many of the words has been distributed in the bigram. Means only two words, two characters are presented, two words means. Okay, and trigram means three words which are going to do that. Okay, all techniques we are going to see that. Okay, next we'll jump into the next pre-processing step as a stemming. Okay, now we understood about the tokenizer concepts, right? Basically this is how you do the first you collect the data, then you will convert the lowercase as a text pre-processing step, then you apply the tokenizer method based on the use case. Like you want to go with the what tokenizer or sentence based tokenizer, then you select and you'll split the data into that accordingly. Okay, then you apply the stemming. This is how the step by step process will follow in the NLP. Even in the interview also, you similarly you can tell that I'll collect the data, I'll convert to the lower, then I'll apply this the various our techniques, then we'll perform that. Okay, let's see what we do in the stemming. Before doing the stemming as well, let's see. Okay, let's see some other special characters removes also. You can do that after you can perform. That is also will coming into the text analysis process only. Okay, let's see. Stemming, will see that first. Reduce the words to their root form. Okay, I told you that like in a sentence, sometimes like, and if you consider for the restaurants, the same information they use multiple times, right? Like, and as you can see that running, run, runner. Okay, love, loves, and loved. Okay, lover. Okay, so all kind of these words is in a root words only, because if you consider number of records, like millions of records, the same word will be represented into the as an like more context or more in detailed. Okay, so why we are doing this text pre-processing and why we are eliminating this unnecessary words means, the more the words, it will occupy the more space, right? More memory space. See, when you're having the more memory space, like when you are passing the more number of words, what will happen? The model training time will be increases. So we wanted to reduce this model training time. That's why we are doing this all the text pre-processing step or text mining steps. Now you people understand why this important, the text pre-processing techniques means each and every operation will plays a key role. Okay, for model training, because if we process all the giant data, the model training time will be it will be taken more time. Okay, so it either takes, sometimes it's 1 day, 2 days, or it's a 1 hour, 2 hours, depends upon your data set size, depends upon the number of words which we have in the data set as well. Okay, so we wanted to eliminate as much as words. Okay, so that we can make the model to be more we can train model more quickly with a shorter span of the time we can do that. Okay, so consider the stemming. So consider the stemming. So whenever, because when you see in the data, so some people will write the same information as in the different of words. Okay, we wanted to eliminate those words, and we wanted to take the valid words only, because the valid words means, here you can see that the valid word will be the love, right? Because of love, slow, love, everything will becomes in the valid word as a love. You can see the running, runner, ran. Okay, so after you do that, you can get the run or ran, right? So this is how we can take we can reduce the number of characters, so that it will eliminate the memory size as well. Okay, to do that, to get the root words, okay, what we do, we use the Porter stemming. Okay, stemming, inside the stemming we have the methods called Porter stemming. Okay, if you want, you can see that what are the other the Porter stemming techniques also we have. Use simply DAR, and you can see that. Okay, all the Porter stemmer, Lancaster stemmer, RSL LPS stemmer, regression experience, rejects stemmer, snowball stemmer, wordnet limitator, all these are the various stemmers. Okay, in interviews also they ask what type of the stemming technique you have applied, like Porter stemmer technique you have applied, or snowball stemmer you have applied, or wordnet limitator you have applied. They will ask you. Okay, so that's why I'm showing you what are the various stemming techniques we have in the NLTK package, which I'm showing you. So currently we are going to use the Porter stemmer, but in your exercises you can explore with the snowball stemmer also. So each and every stemming method have their own set of rules while making these root words, while it is considering the valid word as we are seeing here. Okay, so you can see that. So before we are doing that, as I told you that we are, why we are doing the tokenizer, we are doing the tokenizer to make to consider the words. Okay, because the next operations whichever we are going to perform, those will be in the word level based approach only. Okay, that's why I applied the words. Okay, words I've taken in the list of words. So here I've applied the Porter stemmer. So each and every word I'm running in the loop. Okay, each and every word which I'm running in the iteration based approach, so that I can able to identify that which words need to be considered. Okay, so here you can see that this is a one which you can see that runner and ran, and run is which is came, because running and runner both are will be the similar. But if you can take the one more example, see you can see that. So if the people with written with the same word with the different informations, we are trying to take the valid word. So you can see the best example. So now what we can do, we can remove these duplicate items, right? We can remove these duplicate words with the set approach, set data type. So that what will happen, our the data set size will be reduces, so that we can improve the model training time. Okay, so by reducing the memory size, we can improve the model training time. Okay, so this is why we do the porter stemming technique as well. Okay, let's do, even you can calculate as well after doing the stemming, and before doing the stemming, what was the length size of the words as well. Okay, if you see words real is there, this is the original one, right? We are see length of the word. Okay, you can see 1842 is the number of words which is presented in this list. Okay, if I am doing the stemming, okay, what will happen? See, here I'm supposed to take the length. See, from 1842 tokens, it is reduced to the 695. See how many of the words, the junk words we have eliminated. Okay, this is why the text pre-processing steps is very important, which I say that. Okay, so now you have almost reduced like 100% of your data. Like if you have 1800, from the 1800, like almost 60 to 70% of the data you have eliminated, which is not required for you to be analyzed. Okay, so even if you want, you can see that how this the stem which is applied. See, even we can pre-process the 695 words to the making to the valuable words, means the more contextual words also which we can consider. Okay, so let's jump into the another one. This is a one of the step as a stemming. So stepping will be, you can stemming will be, you can see that when you have the adventures, adventures. Okay, all this comes into the adventure. Okay, when the people write with a different, with the same word with a different approach, okay, we'll try to take the valid word from there. Okay, so that we can reduce the memory size of the our data sets. Okay, this is the one of the example which I can tell in the text pre-processing steps. Okay, next is the lemmatization. See, what is the difference between the lemmatization and stemming means? See, they both work on the same approach to get the valid word. But in the lemmatization, what it will happen, it will try to extract the valid word based on the context based information. So for example, if you have the words like in a better, good, best, when you apply the lemmatization technique, because as we see in the Porter stemming, in the stemming technique, so it looks for the betters. Okay, better, from there it will try to take only the better is a word, good, goods, okay, goody, or best, bestie, okay, best wishes, or some kind of words will be appears. Okay, then the only it looks from the similar words only, from the base root it will try to look the similar words only. But in limitation, what will happen, it will try to extract the words, it will try to take the valid words from the contextual based, because better, good, and best, this both are saying in the positive way, right? So this is what it will try to take of the contextual based information, so that the parts of speech tagging or kind of techniques which we applied in the lemmatization of the backend operation, so that it will extract the valid words only. Now you see, from these three different words, if we extract the one unique word, then it will reduces the my steps as well, right? my training data set sizes. So that is the difference between the stemming and lemmatization. Even in the interviews, they ask you the what is the difference between the stemming and lemmatization. So stemming, just extract the valid words from the given list of words, but in the lemmatization, it extract the valid words based on the context based approach. Okay, so this is the examples which you can tell to your interview side as well. Let's implement. Here you can see the running better feet. Okay, you can see. See, as I told you, this lemmatization will work based on the parts of speech tagging. So here you can providing the as in a verb or noun or non-noun or verb kind of the thing which you can provide it. Okay, from running better feet and everything, it be considered as a run. Okay, even you can make the wordnet lemmatizer, and you can utilize various lemmatizers in the lemmatization techniques as well. Okay, let's jump into the another one, stopwords. Stopword is also one of the very important technique in the NLTK, in the NLP process approach. So what I do now, as you seen here in the data, right, in the original data, like, and if you're going back to the stems, okay, in stems you see that what is mean by stopwords. Stopwords is nothing but these are the like another words which will help these words to make the proper sentences, right? Like, for example, you can consider this is a great example of NLP. Okay, this is a great example of NLP means this is a okay, of these are all the words which is helping to make the sentence. See, by seeing the great and NLP, we can say that NLP is a one of the domain industry in the AI, and we are saying that this is the very interesting and very great field. We are saying that. So great means which we are saying as a positive based approach, and means which are more positive based of word which we can consider. By considering this word, great word and NLP, we can identify that how the person is saying that, what type of the information person is trying to say us, not by this and is or a of. Okay, any kind of these words which is not required to us. Okay, those we call as a stop words. Okay, so in stopwords we have an already we have a predefined stopwords. If you want to use any other external stopwords which is you don't want to utilize for further, then you can extend your stopwords list as well. Okay, so based on that you can remove the unnecessary, the common use words, and you can focus only the meaningful words as I told you in the great and NLP. Okay, so now we will see that. So to implement the stopwords, so even that also can be performed in the NLTK package only. So in the NLTK, you will be having the corpus, and inside the corpus, you will be having the stopwords technique. So with that, you can able to eliminate. Okay. See, you can see that this is my sentence. I have done the word tokenization. Word tokenization, because we have to do the tokenizer, right? Then only we can apply. We can perform the other operations. So this is the when I splitting the word, when I'm doing the word tokenize, this is what I receive. After I'm doing the stop, after I applying the stop words technique, I received only the four words. Okay, here this is a of all words which has been eliminated from a given text. Even you can see in the stop words list also what are the stopwords, existing stopwords we have. So these are all the custom stopwords which is presented in this library. Okay, so if you want, you can add other words also which is not relevant to the your contextual data or the use case which you are working. Okay, won't, same, could not, did not, which is not required for us. Okay, next is one more important is, I hope you guys are following my the techniques, right? If you have any queries, please message in the chat window so that we'll try to answer your questions. Okay. Okay, next is the parts of speech tagging. So as I told you, parts of speech tagging also, which is very very important when you're working for to making a new sentence, or when you're working for when you wanted to generate some new text. Okay, so when you if you wanted to generate any text information, so you need to know that there is a proper sentence which has to be performed, right? So when you are writing any email, the email, there is a recommendation system, right, where it will help you to what type of the words has to be presented in that based on the information which you entered earlier. Okay, all this it will identify because it will see that the particular word you have used, it is a verb based or it is a noun based or it is an adjective based type of the tagging which you are utilizing, or it see all type of information, then it will make sentences. Okay, see, I will give you one example. I was working for the one of the semiconductor industry, which everyone knows, like a name, Intel. So what we do, my as I'm a data scientist there, I will be working for the various use cases. Like in one of the use cases, you can consider the test cases, generating the test cases for the this hardware components when it is working for the when it is audio component when you are when they are testing this process with the audio components, whether the processor performing like an as expected when they are increasing the frequency levels. Okay, so they need to generate these test cases. Okay, then these test cases can be sent to the testing engineer. So based on that, they can perform the all the test cases, like in the inside that what kind of the testing approach as they need to be follow, what kind of the frequency levels has to be they have to utilized while they're doing the testing. So all the kind of test case description can as a data scientist I need to be generated. So when I'm generating the test cases, I need to follow all these rules as well. So there it will be helpful for you to be parts of speech tagging as well. Okay, as you can see there. Okay, the cat sat the mat on the mat. Okay, here you can see the mat is a one the one which has to be praised. Okay, what type of here has to be noun has to be presented or adjective has to be presented, which will be provided here. Okay, even when you are doing the text pre-processing, okay, you know that the text sentence will be follow with the some the set of rules, right? Each and every word will be follow with the noun, with the pronoun, or with the adjective. Okay, so you can define your text, okay, what type of the words which you need to consider as well. So that also you can reduce the you can eliminate the unnecessary words based on the parts of speech tagging step as well. This is also can be implemented in the text pre-processing side as well. Okay, let's implement the parts of speech tagging. You can see here. So what it gives each and every word, how it is defined. Okay, here example you can see that John is eating an apple. So basically when we see any names in the text, we consider as a noun, right? So that's where it is came with the noun. Okay, so like a name other words also which you can see that. Okay, so how will we apply even the pos tagging system also, which is presented in the nltk itself. Okay, you will be having the string will having the multiple words, that words will be created with the tokenizer. With the help of word token we are going to split, and each word will be passed to the pos tagging system so that it provide the information here. Okay, so this is how we'll identify the parts of speech tagging as well. Okay, next we'll jump into the another one. Okay, now consider, before I jump into the converting to the text to the numerical, as I said you, the final step is the from the computer from the human readable to the computer readable language. We are going to do that. Okay, so that is kind of numerical information we are going to generate. So to making the numerical generation, before that we might also see some of the special characters also in the text. We might be see ash or explanatory symbols or dot or like in a question mark symbols, and sometimes there will be some interesting emojis also will be presented. Okay, all this data should be eliminated. Okay, by using the regular expressions or by using the replace is the word which you can utilize in the string, so that you can eliminate this particular patterns as well. So these sessions also will be taken by the tomorrow in the regular expression, when we see these kind of the special character, how do we handle in the string as well. So by providing all the special tags together, we can eliminate the information. Okay, so those kind of interesting steps also we will going to perform tomorrow. And this is a one of the step also in the text pre-processing and eliminating the special characters. They will ask you how will you eliminate the special characters in your data as well, because as you seen in your email data, right, one of the real data where you see all kind of this chunk data also. See this USX. Sometimes there will be at the rate gmail.com also will be presented. Might be this it is not presented here. So those kind of also informations will be available. Okay. And because they ask you how do you handle this email based like an at the rate of gmail.com or at the rate of information if it is presented in your data also. This all can be replaced in the with the regular expressions, and with the NLTK only we can use the various other techniques to reject parsers to eliminate this kind of information as well. Okay, all these steps will we are going to perform on the text pre-processing side or text cleaning. Then we are going to do in the all the if we completed about if we remove all the informations, okay, all the texting cleaning part is done means then we are going to convert the useful word or meaningful words into the numerical words. So how we are going to do the meaningful words? So there are multiple techniques in the NLP. So that one of the technique is called bag of word model, and the another technique we are going to call continuous seabow technique, we can tell that. That is a continuous bag of word model, and there will be the word to vector, and there will be the universal sentence encoder, and there will be the like in a word embedding with the generative APIs also we can perform. So all the various the techniques will be provided to the numerical values only. Each and every operation, each and every mechanism have their own calculation in the background. Okay, some of the bag of word model, like, and if you consider the bag of word model, it will generate any word. It will first, it will what it do, it will see that number of sentences and what are the unique words which is presented. So each and every word it will create as in a one column. Okay, and then it will replace as a one. If this word is presented in the sentence, it makes as a one. Okay, and or else it makes as a zero. This is how it makes the calculation part in the background. Okay, you are not going to perform anything, but this is the background. Actually it works, just you are going to apply the package, and you are going to pass this text information. That itself it will convert to the numerical values as you see here. Okay, so here you are going to use the scikit-learn package to perform this text to the numerical. We are going to use in interesting framework as a scikit-learn. So this scikit-learn, this all the steps which you are going to do the future extraction. How we are going to do the text to future extraction means we are going to convert the human readable language, human readable information to the machine readable information. That we process, that we steps we call as a future extraction process. So for that we are going to use counter vectorizer and bag of word model. Okay, so here you can see the text, and here I've used the counter vectorizer, and then I'm using the fit underscore transformer. I mean, fit is nothing but I'm going to no, provide all my words to the fit, then I'm going to train that. So fit and transformer, it will take as an input, and it will process, and it will train it as well. Okay, so you can see that. Okay, so all this, the each and every sentences which is been converted to the numerical words. And if you wanted to see that what this particular word, like in how it is represented, what are the words which has been taken, you can see that the get future name underscore out. Okay, with this vectorizer output, you can see the list of words which has been considered. Okay, these are the words which I've taken. If suppose I've added the one more word called, anaconda. See, now anaconda is a one more word also which is added here. Okay, so if you see the same word, think that if I added in the same sentence, what you do, see, anaconda is a one word, like it as I told you. You can see that that's why one is represented in the two places. Okay, so it won't create the same word as a multiple columns. So it will create the unique columns as a based on the words which is presented in the given text. Okay, this is how it works in the counter vector word vectorizer or the backer word model as well. Let me take you to the backer word. Second. Yeah, similarly, you can apply. I'll just show you that example as well, which is I've not taken here, but let me see that. Okay, next is As I told you, the TF-IDF is also one of the vectorizer, one of the operation which can be utilized for text to the numerical approach. Okay, many people also they ask you on the questions on the TF-IDF approach as well. So why how the TF-IDF will be calculated here? Okay, weighting mechanism it will try to take consider. Okay, so weighting mechanism means suppose you have seen the in Excel you are seeing the each and every row, right? Each and every row we consider as a document here. Okay, if you select the C column, you can see the number of documents presented are 17,000 documents are presented. So what it do, so it will take the one word, and in the document, if you consider this is the one document, so inside the document this particular word how many times it is presented. So based on that it will take the frequency, and then it will look for the other documents like in this particular document and another documents. So it will count the number of times appears into the other document. Based on that it will calculate the final score, and it will take you the highest score. Okay, whether that word is in a meaningful word or which is not the meaningful word. Okay, based on this approach which will be works actually. Okay, here you can see that this is the TF-IDF mechanism. So you can use the scikit-learn only, but here with the TF-IDF vectorizer you are going to do that. Okay, see you can see that. Okay, here you earlier you are seeing 1 0, right? But here you are going to see the 0 to 1. In between that you are going to calculate the score. The higher the weight, the higher the score you can consider that is the meaningful word, and which is higher weight for the our analysis. Okay, this all these operations which can be calculated from the mathematical in the background. Okay, and you can see that whichever the words which is converted you can get from the get futures names out, and you can able to say that as well. Okay, list of words which is converted. Okay, so here also same fit and transformer which you are going to utilize and which you are going to perform that. Okay, see each and every mathematical operations which have their own set of rules, okay, to calculating the information. So that's why each and every embedding will have their own scoring mechanism and their own the score extracting the future side information as well. Okay, next you can store this in vectorizer also with the using the pickle or JSON format or some other data type format also, like in a the file landing methods. So there you can reuse these vectorizers in the future when you wanted to predict for the new features. You can reuse this the stored vectorizer. Then you can reload and you can perform the any additional informations as well. Like, and as you see here, okay, you can see that this additional informations also can be performed by using the help of transform keyword. Okay, so this is also we can do that. Next you can see the word to vector also. This is the word to vector can be implemented with the gensim packages. Okay, gensim is also one of the important the package where we can do the various NLP operation doing the any named entity recognition system. And you want to calculate it, the two sentence how these two sentences are similar together. So all kind of like the various cosine similarity and other word to word mover distances, all the semantic similarity operations also can be performed in the gensim package. So what to vector you can create your own what to vector models also based on your data. So this is how it will give the scores. You can see the scores from the vectorizer to vectorizers. Each scoring vector, each every embedding method have their own scores here. Okay, calculating of that, and there will be the average what to vector. So here what it do, it will take the average of this particular document, okay, for each and every of the word. So that is known as the average vector. Okay, this is the advanced NLP techniques we can tell that. And there is one more interesting topic is a spell check system as well. See, as I told you, when we are analyzing the data, when we are seeing that email information need to be classified, or the person the email which is written, how the email context which is saying means, sometimes when we are writing the any informations, so that information might be some spell mistakes will also will be happen. So based on the spell mistakes also what will happen, instead of the, okay, if they written as a th, then we consider as a different one, right? So these issues as typo errors issues has to also need to be handled. This is also comes from the picture of the NLP only. Okay, spell check systems as well. So for that, you can apply various things as well. Like, and I will show you how to handle the spell correction. So you can see that. So you can use the text blob and other packages as well to handle this spell checkers. Okay, like text blocks, sim spell, okay, py spell checker, unspell. All these packages will help you to fix the spelling issues. So you can see that right here. Error. There is an error which is a typo error which is there. You can, it is there. It is fixed. Okay, this is how we can able to handle the spell checker information as well. And even you can do the keyword extraction also. For given any information, you can able to extract the in meaningful words also, that can be do from the space that we can call as a named entity recognition systems as well. Okay, so this is how we can perform the various text pre-processing in the NLP side. Okay, you can see that word cloud also, like in the number of based on the same words how many times is appeared. You can see that the bigger size of the word can be considered as a, it has repeated multiple times, it is the highest repeated time. Okay, so you can see the word cloud also, it is encoded. You can decode also. We need to use another mechanism to decrease. Okay, so then we can see that this is a one kind of the various pre-processing. If you see in the real-time approach, like in the same data set which I've taken the review, like in a sentiment and restaurant reviews, you want to perform some sentiment analysis. How will you do? So in the real time, I'm saying whenever you receive the your data sets first, okay, as soon as what you do, you're going to perform this text pre-processing steps, like as we are learned here, like tokenizations, like this is how will be applied. Next, word tokenizer and frequency distribution of the frequency, like as we are seeing the cloud word cloud package, right? You can see that each word how many times it is appeared. Okay, next you can see the some kind of, by plotting the techniques as well, you can analyze like each word how many times is appeared, and you can see that with a visual based appearance as well. So if you see in the project based, like here, as soon as read the packet, the data set, you can see that. So this is my data set, which is having 1,000 rows. Okay. Now, as I told you that immediately I will do that, because this is a chunk data which is not required to us to perform any analysis, right? So I will remove, because here you see that not is also required, because you can say that he is not interested in that particular information. We can say the is which is not required for us, I is not required, if is not required, as is not required, then is not required, off is not required for us. Okay, all these operations you can perform with the here actually. Okay, so you can see that you are reading the record one by one with the for loop, and you are converting to the lower case, you are splitting, that is a tokenizer you can apply. Then you are applying the porter stammer, and then you are combining all together. Okay, uh, yeah, it is taking little time because of 1,000 records is there, right? Yeah, it is done. So you can see that now all the words which is came to the standard words, and it is removed the stop words and other words as well. You can apply the lemmatization as well. So you can see the bag of word model as in a counter vectorizer here. You can apply the counter vectorizer. You can see this is how you applied. If you want, you can apply the other, like, and if you want, then you are going to fit the data. This is how your training data will look like. Oh, sorry, it is in a special yeah, this is how it will look. Once you convert it to the numerical part, then you are going to train the model. Okay, that is what the model selection, like you are going to split the data, then you are going to apply the model. Okay, as an Navi base, or like in a LSTM or RNN, any model which you are going to take in. Okay, this is what we are going to do. Okay, so this is about the NLP.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.